Hi, Assalamualaikum. We want to present about Atterberg limit of cone penetration method from code DCC 30112, which is Geotechnical and Highway Engineering Laboratory. We from class DKA 3A, and the lecturer who gave this assignment is Puan Nur Asiah binti Ahmad. Let me introduce myself. I am Nur Ambakis F2023 and my teammate is Nur Nabiha Uzma F2032, Shazvin Rush F1053. Introduction. The cone penetration test has been successfully used to classify soil over 100 years. This test is used for profiling soil layer and for deriving soil properties, such as density, shear strength, angle of internal friction, and torsion. Different types of mechanical and electric cone penetrometers exist, but the electric cone is most widely used. A steel rod with a conical tip was pushed into the soil. The penetration resistance at the tip and along a section of the shaft was measured. In this laboratory activity, we were exposed to the usage of Atterberg limit test to determine the liquid limit of a given soil sample using cone penetration method. Objective: to determine the liquid limit of the soil sample. Theory: in the cone penetration test (CPT), a cone on the end of a series of rods is pushed into the ground at a constant rate, and continuous measurements are made of the resistance to penetration of the cone and to a surface lift.
Hi, my name is Nora Bihaus Mabinti Hazri. My metric number is 01DK80F2032. Today, I will present about apparatus. First is oval laboratory. Second is balance laboratory. Third is Seaver. 4 is cone penetrometer. 5 is water, and the last metal cup.
Hello everyone. Before I begin, let me start by introducing myself at first. My name is Shashvin Raj, son of Bhaskar Naidu, and my registration number is 01DK820F1053. And as you all know, I'm from section DK3. So I'm here today to explain the part of procedures or the process of the cone penetration method of Atterberg limits. So let's take a look. Firstly, we should take a soil sample for about 250 grams that has been past the sieve size of 425. Mix the soil sample with distilled water in the porcelain container until it forms a soil and paste. Mix the soil paste on the glass plate with the spatulas for at least 10 minutes if necessary. Add more distilled water to give cone penetration 15 mm, which means 15 millimeters, and mix well in. Press the soil paste against the side of the cup to avoid trapping air. Press more paste into the bottom of the cup without creating an air pocket. Fill the middle and press well down. Use small spatula. The top surface is finally smoothed off well with rain using the straight edge. So let's take a look at another procedures in the next slide. Okay, now fifthly, we should hold the cone, press release button, and adjust the height of the cone so that the tip of it just touches the soil surface. The vertical clamp is then released, allowing the cone to penetrate into soil paste under its own weight for 5 seconds. After 5 seconds, the penetration of the cone is noted to the nearest millimeter. Seventhly, the test is prepared at least to have 4 types or else 4 sets of values of penetration in the range of 14 millimeters to 28 millimeters as well. So lastly, the exact moisture content of each trial should be determined. Okay, now let's take a look at the data analysis of the cone penetration method in Atterberg limits. So firstly, we just inserted a random data and a random graph, which is not related to our particular work because we haven't done that in real, because it's just a virtual classes is ongoing at the moment. So let's take a look at the formulas that we should, how to calculate the liquid limit as well. So as you can see, I have inserted a table. The table states there like the calculation of liquid limits. So the first formula that we have used is ms equals to mcds, which subtracted with mc, and the second one is mw is equivalent with mcms subtracted with mcds, and the third one is w is equal with bracket mw over ms bracket. So these are the formulas that we have been used, and at down you can take a look at the table as well, which the moisture can should be added with the lid number. And also the secondly, we should what does the mc means? Mc means we should add mass of empty can and also the lids, and mcms mean we should mass of can added with the lid and also added with the moist soil as well. And the fourth one, mass of soils, which equivalent with ms, and the fifth one is like mw, which is mass of pore water, and the w is equivalent with water content. So the lastly we will get the penetration value in millimeters as well. So the second one, you can take a look, there is a graph that we should be plotted with the value that we gained from the data analysis that we have done. So we should plot the graph as well as shown in that picture. So this is the diagram which shows the liquid limit cone penetration method graph. So that's all for me. I will pass to my next teammate to explain their part as well too. Thank you.
Discussion. Once the result has been taken and the graph has been plotted, the liquid limit can be obtained from the penetration vs moisture content graph. The graph represented water content on y-axis and the cone penetration on x-axis was prepared. A best-fitting straight line is then drawn to make use. It was stable. The moisture content corresponding to cone penetration of 20 mm was taken as the liquid limit of the soil. The result has taken from record data from moisture content and penetration. For sample number 1, it has 51.91% of water content and 6 mm of penetration, while sample number 2, it has 62.85% of water content and 7.9 mm of penetration. And for the sample number 3, it has 70.4% of water content and 15 mm of penetration. Lastly, sample number 4 has 77.98% of water content and 22 mm of penetration. In order to get the percent of water content, the mass of pore water has been divided with the mass of solid, while the liquid limit that taken from the graph was 76.4%. Lastly, to obtain the best result for the liquid limit, the weight salt taken in the container for moisture content determination must not be left open in the air, and the container with soil sampler must immediately be wiped. After mixing the soil with water, a sufficient time must also be given to permeate the water throughout the soil mass. Conclusion. In conclusion, based on this cone penetration test, we successfully obtained the percent of liquid limit. In order to get an accurate result of the depth of penetration when using penetrometer, we must make sure the tip of cone just touch the surface of the soil sample. Ensure that it don't sink even slightly from the surface of soil sample because it will affect the reading of the penetration. That's all from me and my team. Thank you.